Tonight's curiosity is aided by Moon Lake Dark Ale from Farmery Brewing in Neepawa, Manitoba. They have no tasting notes or anything on the can. They're just pointing out that they are a real farm and real farmers. And yeah, Farmery is an estate brewery, which means that they grow the grain, the hops, and they actually brew the beer all on their farm at Neepawa. That is quite malty, very nice indeed. So today I am looking at this solar LED bug zapper and path light all in one little unit that I picked up, of course, at Dollarama. Source of cheap crap that I don't have to wait for shipping from China. Let's see what the claims in the box are. No wiring required, install anywhere. Oh yeah, it's a solar spike light. Waterproof grade for all weathers. Sure, okay, we'll see how waterproof it is. Effectively helps you get rid of annoying mosquitoes, skeeters, and houseflies. Safe for humans and pets. Sure. Okay. I don't know what the difference between mosquitoes and skeeters is, but whatever. Oh, it has modes. It has 2 modes. On number 1 is bug zapper mode. On number 2 is a soft light. So let's see what we get in the box. We get the unit itself, a spike piece, and a little riser piece. How does that go together? Sure, like that. Altogether, it is about 45 centimeters long. Don't care about that part for this, what we're doing. A solar panel on top with a peel thing. Get ready, you know what's coming. So, on the bottom here, we have this cage piece that protects you from hurting yourself and stays out of the way. On a 3-position switch, on 1, off, and on 2. If I remember from the box, on 2 is the peaceful, gentle light, and on 1 is the murderous version. We have a little battery compartment in here. What is that? It has a 200 milliamp hour, 1.2 volt NiCad. Wow. NiCads are still used for something. Ancient technology, but I guess in a torturous little environment like this, all weather, being trickle charged constantly, why not? And we got 3 screws there and 2 more screws there that we can take apart later. So let's see if this thing, let's see what it does. On 2, that is just the nightlight mode, and with the solar panel darkened, nothing happens. How about on 1 mode? Same, I don't see anything. I guess that would explain why the battery is dead. Let's see if that battery will charge under my fairly bright lights in here. Let's see, we get probes in there, measure the voltage, 0.2 volts. Okay, yeah, it is climbing. Slowly, but it's climbing. Get it closer to the bright lights. That's going to take a while. So I'm just going to get a couple little magnets here and stick them on there. Stick my power supply on there, set for 1.2 volts. Turn that on, and it's like we're charging at 5 or 6 milliamps. Okay, I'll just let that cook off to the side here. We'll carry on our testing with a half-discharged alkaline cell. It'll do the job. Obviously, I'm not going to try and charge it, but it should do the job anyway. So now then, if we turn it to on 2, now we get a cool white light. And if we turn it to on 1, oh, we get kind of a pseudo-infrared light. Okay. So the bug zapper is basically this grid of wires here. Oh, and some of them are kind of bent. As long as they're not touching each other. There's the 2 ends of the wires. Let me just separate a few more just so we don't have any inadvertent shorts. Because the short circuit that we want is a bug landing across there, trying to get to that deep purple pseudo ultraviolet light inside there. And then he lands across there, and there is a high voltage across the 2 of those wires, and that causes Mr. Bug to explode, theoretically. Now, I don't know what that voltage is, but maybe we can find out. Let's turn that to on one mode. Looks like we're getting up to about, wow, 470 volts. Okay. So if a bug lands across that, it should get his attention. Let's see what happens. Oh yeah. Takes a bit of time to recharge, but that definitely does the job. Let's turn that off. Does it discharge itself automatically? No, it doesn't. It retains a charge. Okay, that's useful to know. But now it doesn't have a charge on it, so let's open it up and see what's inside. My guess is it's going to be a couple of fairly common bits of circuitry strapped together, but we shall see. So we have two wires coming from the solar panel up here, and two wires coming from the battery compartment up there. We have the main capacitor, which is going to be across, it's across the death wires there. That one is charged up from presumably a little oscillator on here to that 400 and whatever volts we saw. That capacitor is a 470 nanofarad 400 volt. Ooh, they're pushing it harder than that capacitor should want to go. That's not ideal. It's not surprising that they're abusing it, but it's, you know, not really ideal. Let's get the circuit board off and see if there's anything else on the back of it, or if it's just a single-sided board. Oh yes, there is some things on the back side of it. There is the two LEDs, a cool white and a pseudo ultraviolet. We have a transformer, that'll be for the voltage boost. We have, I'm going to guess that's an inductor, and then we have a 4-pin chip there, which is going to be the standard garden light solar charge voltage boost, using that inductor to create, 3 or 4 volts to light the LEDs out of a 1.5 volt battery. Which means all the stuff on this side is going to be to do with the voltage boost to get up to the 600 volts to obliterate insects. That looks like 4 diodes, which would be rectifying the frequency coming out of the transformer. The transformer will be boosting the voltage up, which means that these components over here, looks like we've got 2 transistors of different types. We've got a component in there which it has a number on the board, 4148, is that what that is? Maybe a diode? And then just some resistors and capacitors. I'm going to draw this thing out. I'm going to look up those transistors, and I will be back to you momentarily. Time has passed, and I think I've come up with a schematic that makes sense. I've broken it up into 2 different pieces. Here is the first piece that lights the LEDs and deals with the solar and the battery charging and everything else. So we have battery positive, solar minus, and battery minus, which are tied together there. The solar positive just goes into the little 4-pin chip, which is a YX8051. That's a solar lawn light LED kind of thing, as you can see here. But solar lawn chip LED driver is exactly what it is, a little 4-pin chip. And there is the fairly standard schematic for the thing. The only thing that it doesn't have is this capacitor and this Schottky diode. It's, I guess, just using the LED as the diode, strangely. Whatever. That is how that guy works. So the battery positive goes to the center pole of one side of this dual pole, dual throw switch. So when the switch is in the upper position, these 2 are connected and these 2 are connected, and these are disconnected. When the switch is in the lower position, or the other on position, then these 2 are connected and these 2 are connected, and there's no connections up here. So let's pretend that the switch is in the upper position. So it connects the battery to the voltage input of this, The lighting output uses the magic inside this to oscillate, bounce this inductor, boost the voltage as the data sheet shows. And that lighting voltage comes out here, which is in the 3-4 volt range, a few hundred or a few dozen milliamps, enough to light an LED. And since our switch is in the top position, that goes here and through this LED and out. And there's not enough current available to burn the LED out, so it doesn't need a resistor, though you probably should have one, whatever. So if the switch is switched in the other position down here, exactly the same thing happens, except for the voltage goes to this LED, which is the purpley ultraviolet one. But also the same voltage, 3-ish volts, goes out to the high voltage circuit. And here is that circuit, which is a bit more complex, but nothing we can't wrap our brains around. So here is that switched voltage. It's not 1.2 volts, it's the LED voltage. It's about 3 volts, give or take. That comes in to the base of this PNP transistor, which is that one there for anyone playing along. The collector of that guy goes out through this little Schottky diode. We have a handful of capacitors there to ground just for bypassing, but goes through the Schottky diode, through a couple of series resistors to the base of this guy, through another capacitor to the center tap, and to the base of this NPN transistor to the other end of this transformer. Long story short, that all forms an oscillator using that inductor, the transistors, the capacitors, and that just oscillates away at 3-ish volts. On the other side of the transformer, this transformer that's on the back side of the board, we have our 3-ish volts there just as a reference. And this is a significant step up transformer. But then we encounter this little circuit here. Have you seen this guy before? It is a voltage multiplier. In this configuration with 4 diodes and 4 capacitors, this is going to quadruple the voltage that's here and also rectify it into DC at the same time. But more importantly, as each diode passes current, it's charging up the capacitors. The capacitor voltage is adding to the voltage coming from the previous diode. And as I said, 2 of them will be a voltage doubler, 4 of them is a voltage quadrupler. I'll link a Wikipedia article down below just to explain that whole thing, because I'm not going to go into all the theory right now. Anyway, that voltage goes out to charge up the 470 nanofarad capacitor to, what were we saying, about 450 volts or something, even though it's a 400 volt rated capacitor. Naughty. But then that capacitor, as we said before, goes across the mosquito killing grid and zaps your bugs. Assuming that the bugs are attracted to the pseudo UV light that's in there. And to test that out, I'm going to take the battery, which I have charged. It didn't take all that long, being a 200 milliamp hour battery. I don't know how much current this thing's going to draw. I suspect it's only going to run for a couple of hours. But whatever. I'm going to put this thing back together, and I will stick it out in the yard for a couple of nights just to see if it actually does what it claims to do. Reassembly should be fairly straightforward. There's a little notch there, and run the screws in, and we'll just see what happens. I'll film an epilogue in a couple of days, but I think that's it for the main part of this video. So there it is deployed outside. It doesn't throw much light when it's in bug mode. As a matter of fact, I can't even use the light that it's emitting to see my hand or anything, but there it is. We'll check in a couple of days and see what the pile of dead bugs around it looks like. A few days have passed. Let's take a look at this thing and see what it's been doing. I can tell you that I am disappointed. We shall see just how disappointed I should be, though. First of all, the non-disappointing part. It actually did kill some bugs. Not many, but it did kill some. So that's 1 point in its favor. However, it only ran for about 2.5 hours on a fully charged battery. And as you recall from earlier in the video, I charged this externally and then dropped it into there. So it started off fully charged. It only lasted, like I said, 2.5 hours, which for 200 milliamp hour cell, I suppose that's not horrible for what it's doing. Although I do note that that weighs absolutely nothing compared to an alkaline cell or this nickel metal hydride, which is, what is that one, claimed to be 2100 milliamp hours. So I guess I shouldn't have expected much out of that. But the other thing I discovered, and I should have tested this earlier, but I discovered that the solar panel does not actually recharge this battery to a usable level while this thing is sitting in the full sun for a full day. I brought this in after, again, a full day in the full cloudless sun, and there's almost nothing in it. Generously 0.2 volts, which is, okay, there we go, 0.2 volts. So pretty much useless. That's not enough to power that thing on. So that is disappointing, and I'm assuming that's because this solar panel is just small and inadequate. If we give this solar cell lots of light to play with here, it is generating very, very little through the charge chip. That's what that turned off. Let's turn it on into the blue light mode. Okay. So it looks like it's putting out just 0.5 volt. Wow. So that alone tells me that this thing is completely useless because it'll never charge up a cell like that. Let's just try this with the solar cell directly on that light again and measure directly across the solar cell with nothing else involved. 1.14, 1.15 volts. That should be enough to charge the thing. So maybe that solar lawn light chip in there is not correctly operating in the circuit. There is a couple of differences in the circuit that I found on the board and the sample circuit in the data sheet. There's a diode and a capacitor that aren't on this one, so that may be doing it. I never really expected this thing to be a fine piece of instrumentation, but I had kind of hoped that it would, do what it claimed to do on the box. Regardless, if you see these things in Dollarama, I would opt not to buy one just for that reason alone. But if you were to power it externally, it does in fact kill bugs. So I don't know, maybe there is some use to it, just not how it's advertised. Anyway, thanks for watching. I don't think I've got much more to say about this thing. Questions and comments down below as usual. I'll talk to you later.